Right. Someone reply me if you can hear me speaking. Reply if you can hear me speaking. Quickly. Reply. Right. 1998 11. Then we'll discuss about 2011 11. First we'll discuss 1998 A level. Then we'll come to 2011 A level. In that tute, in my gravitational field tute, you can find 1998 A level question. Right. Okay. If I discuss those two questions, then I discussed all the MCQs from gravitational field, all the essays from gravitational field from 1990 to 2022 A level. Then I did my job in unified gravitational field. Right. 1998 A level. Right. 1998 A level in gravitational field. Gravitational field. Right. 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 Now let's read that question. Write down Newton's law of gravitation in the form of an expression identifying the symbols used. Write down Newton's law of gravitation in the form of an expression identifying the symbols used. Now you know that Newton's law of gravitation. Newton's law of gravitation. When there are two masses, Newton's law of gravitation. 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 Suppose when there are two masses, let's say capital M and simple M, there are two masses. Let's say capital M and simple M masses. There are two masses. Right. But then the distance between capital M and simple M masses is simple r. The distance from their centers is simple r. I explained that when there are masses, there are attraction forces. Now here there are two masses. There are attraction forces between these two masses. Then we know that capital F gravitational force on simple limb mass by capital limb. Now here, when you consider capital limb mass, gravitational force on capital limb mass by simple limb. These two forces are attraction forces equal in magnitude, opposite in direction. Equal magnitude, opposite in direction. Then we know that capital F equals G capital M simple M over R squared. Newton told that gravitational forces between two masses directly proportional to multiplication of their masses, inversely proportional to distance squared. Then you know what is capital G. Then you want to define the terms capital G. Here capital G means universal gravitational constant. Capital G, universal gravitational constant. Universal gravitational constant. Constant. Then what is this simple r? Distance between two masses. Simple r. Distance between the masses. Distance between the masses. Distance between the masses. Then what else? Capital M and simple M. Masses. Capital M comma simple M. They are masses. They are masses. Masses. in G capital M simple lim R. What is capital F? A gravitational force between two masses. Capital F, a gravitational force between masses. Gravitational force between masses. Capital F, gravitational force between masses. Between masses. Then that section is done. That is done. Very basic idea. Okay, now question says, write down Newton's law of gravitation in the form of an expression. I redefine the symbols used, right? Obtain an expression for the acceleration due to gravity. Obtain an expression for the acceleration due to gravity. That means gravitational acceleration at the surface of the earth in terms of mass and radius. Obtain an expression for the gravitational acceleration at the surface of the earth in terms of capital M and radius capital R of the earth. Gravitational acceleration. Now what do you do? Right? Look at it. Right. Now we know that uh, that case, this if I draw the earth, if I draw my earth, what is my earth? Radius of the earth, I would say that radius of the earth, I say capital R, and let's say mass of the earth, capital M. Just think that, just think about a mass on the surface of the earth. Just consider mass, simple M. If you consider mass, now you need to prove that gravitational acceleration, you need to show that gravitational acceleration on the surface, gravitational acceleration at the surface of the earth in terms of mass of the earth and radius of the earth, capital R. You can include capital G as well. You can include capital G as well. You need to find gravitational acceleration at the surface of the earth in terms of capital M and capital R. That's your goal. That's your goal. When you consider a mass, I see this mass is simple M. This mass simple M mass. Simple M mass. Then the force, weight force is mg, right? We can write down if this simple M mass is closer to the surface of the earth. If this mass is closer to surface of the earth, I can write down the weight as weight, if not gravitational force, right? I can write down this mass weight, if not gravitational force. We can see the weight, if not we call it as gravitational force. I can write down weight of this mass, W equals, we can write down W equals mg. Am I correct? Mass into gravitational acceleration. If not, one can write down, weight of this object. Weight means gravitational force. I just take your notes and refer it. This derivation is in your notebook, right? We can write down weight of this mass, W. The weight of the mass means gravitational force, capital F. So therefore, we can write down W equals G capital M simple M over R squared. Because weight means nothing but gravitational force. G capital M simple M over capital R squared. This is your equation. Now my goal is to find gravitational acceleration in terms of capital M and capital R. From equation 1 and 2 we can write down. Mg equals, now you need to find G, mg equals G capital M simple M over R squared. Here simple limb get cancel out. then we can write down gravitational acceleration equals G capital M over R square. Therefore, one can write down gravitational acceleration G, that is equal G capital M over R square. It's a very important equation. I taught these things. You have, when you refer your note, you can find this. Next. Now, next. A satellite of 1000 kilogram is placed in a circular orbit. A satellite of 1000 kilogram is placed in a circular orbit so that it goes round the Earth 10 times a day. A satellite of 1000 kilogram is placed in a circular orbit so that it goes round the Earth 10 times a day. 10 times a day. The radius of the Earth is 6.4 to the power 6 meters. Find the height of its orbit from the surface of the Earth. Find the height of its orbit from the surface of the Earth. Right. Now very carefully listen. Now we did very similar questions. We did very similar questions. It's not difficult. Now if you draw the Earth, now we can see this as our Earth. It's our Earth. Now let's say radius of the Earth is capital R. Radius of the Earth, that is capital R. Radius, that is capital R. Radius capital R. Now there's a satellite. Mass of the satellite is 1000 kilograms. Mass of the satellite is 1000 kilograms. Simple limit is 1000 kilograms. The satellite is orbiting around an orbit. This is my orbit. We'll see this as our orbit. Satellite is orbiting around this orbit. The distance to the orbit from the surface of the Earth is simple h. The distance to the orbit from the surface of the Earth, let's say simple h. Distance to the orbit from the surface of the Earth, let's say simple h. Simple h. Now here is our satellite. Here is our satellite. Right? Satellite. Then satellite, its mass, they have given mass of the satellite, simple limb. Mass of the satellite, simple limb, given as 1000 kilograms. Mass given as 1000 kilograms. What else? They mention radius of the Earth 6.4 10 to the power 6 meters. Radius of the Earth, capital R. Capital R is given 6.4 10 to the power 6 meters. 10 to the power 6 meters. What else? Given data. Very important data they have given. Satellite goes around the Earth 10 times a day. Now, what is time period? Time taken for one oscillation. Time taken for one complete circular motion, that's what we call as time period. Now, they mentioned this satellite goes 10 rounds per day. If the satellite goes 10 rounds per day, what is the time taken to complete one round? 1 over 10 day. Very careful understand now. 10 rounds within 24 hours. Now, 1 day means 24 hours. This satellite moves 10 rounds, if not 10 circular motions within 24 hours. If not 1 day, it moves 10 rounds, if not 10 circular motions within 1 day. Then if you want to find the time taken for one circular motion, we need to divide 1 day by 10. So therefore, I can say that time period of the satellite, capital T, equals 1 over 10 days. 1 over 10 days. 1 over 10 days. Now what we need to find? Now we need to find that, find the height. Roman number 1, find the height of its orbit. Find the height of its orbit from the surface of the earth. We need to find simple h. Identify simple h. Now satellite moves in a circular motion. Satellite moves in circular motion. I say its angular velocity, that is omega, tangential velocity, that is capital V, gravitational force, that is capital F. Capital F. Then consider the circular motion of the satellite. Roman number 1. If I consider circular motion of the satellite, if I apply F equals ma, satellite, if I apply F equals ma, F equals ma to the center, applying F equals ma to the center, then what is my capital F? My capital F will be, gravitational force. Mass of the satellite is simple m. Mass of the earth, I say it as capital M. Mass of the earth will consider as capital M. Mass of the earth will consider as capital M. Right. Then I can write down gravitational force as, gravitational force I can write down G capital M simple M, G capital M simple M over distance r square. G capital M simple M over r square. What is r? The distance from the center of the earth to the satellite. Distance from the center of the earth to the satellite. Capital R plus simple h. Capital R plus simple h. Capital R plus simple h. Capital R plus simple h whole square. This must be equal to m centripetal acceleration. Right, but now centripetal acceleration I can write down in two different ways. Centripetal acceleration can be written as v squared over r. Tangential velocity squared over r, right? Centripetal acceleration we can write down tangential velocity squared over r. If not, centripetal acceleration can be written as r omega squared. Now I know time period. Therefore, I thought that writing centripetal acceleration in terms of r omega squared. I thought of writing centripetal acceleration in terms of r omega squared. M r omega squared. R omega squared. Right, now I need to find simple h. Now what is my r? R means orbital radius. My orbital radius is again simple h plus capital R. My orbital radius measured from the center of the earth. Orbital radius is simple h plus capital R. Capital R plus simple h. Capital R plus simple h. Omega squared. Then here simple m cancel out. Simple m cancel out. Can you remember? Now they didn't give mass of the earth, right? They didn't give mass of the earth, but they have given radius of the earth. They have given radius of the earth. They didn't give mass of the earth, but they have given radius of the earth, right? Then can you remember I told that suppose if they have given radius and gravitational acceleration on the surface, that is 10, gravitational acceleration on the surface, that's 10, then how do you find, instead of G capital M, because I don't know capital M value, I don't know mass of the earth, so therefore I can replace G capital M by simple G capital R squared. I can replace, look at here, G capital M by, I can replace G capital M by simple G gravitational acceleration R squared, radius of the earth, over R plus simple h, R plus simple h, R plus simple h squared equals, now G capital M is replaced by G capital R squared, R plus simple h squared. If I bring this one on this side, R plus h cube, R plus h cube omega. Now we know that time period equals, I think you know that time period means 2 pi over omega. If you can remember this equation, I can write an omega as, 2 pi over capital T, because I know time period. So therefore I can write an omega as 2 phi over capital T. 2 phi over capital T whole square. Whole square. Right. Whole square. Now I need to find right whole square. Right. Okay. Raise your hands up to now. Everything is clear. Raise your hands up to now. Everything is very clear. Now my target is subjecting simple h. My target is subjecting simple h. How do I solve the simple h? How do I solve the simple h? Right? Uh, I can do something like this. I will bring r plus simple h cube that side. If I bring this one this side, I can write down g capital R square, g capital R square, t square. If I expand the bracket, 4 phi squared over t squared, this t squared. If I bring this side, g capital R square, t squared over 4 phi squared, 4 phi squared, a t squared, 4 phi squared equals r r plus simple h, r plus simple h cube, r plus simple h cube r plus simple h cube. Then if I further simplify, right, then I can say that r plus simple h, r plus simple h, r plus simple h equals r plus simple h equals r plus simple h equals g capital R squared, capital T squared, 4 phi squared, 4 phi squared. If I take both sides power 1 over 3, if I want to subject r plus simple h, I need to move this power this side. That means 1 over 3. 1 over 3. Power is 1 over 3. 1 over 3. Now I substitute. Radius is 6.4 to the power 6. Radius 6.4. Radius 6.4 to the power 6. Plus height is simple h simple h plus simple h equals value of g is 10. Now capital R again 6.4 square 6.4 10 to the power 6 whole square 6.4 to the power 6 whole square. Therefore 6.4 square 10 to the power 12, right? 10 to the power 12. Time period 0.1 1 not means 0.1 days. 0.1 days. 0.1 day means 24 hours, 3600 seconds squared, right? Over 4 into 3.14 squared. Power is 1 over 3. Power is 1 over 3. Power is 1 over 3. Right? Power is 1 over 3. Okay. Right. Did you understand up to now? Raise your hands. If you understood, raise your hand. If you understood up to now, raise your hands. If you understood, raise your hands. Right. So then log simplification is there. Then log simplification is there. Then log simplification is there. Right. Now log simplification is there. Right. Now. Now what shall we do now? You want to simplify this one. That's the problem. Simplify this one. How do we simplify this one? Now need to take log. Without log we can't simplify. We need to take log. Right, okay, anyhow we'll simplify this one, however. Right, anyways, we'll simplify. Now look at it now, 0.1 into 3060. Okay, then I can write down 6.4 to the power 6 6.4 10 to the power 6 plus simple h equals right 10 to the power 13 10 into the power 12 means 10 to the power 13 10 to the power 13 ni 10 to the power 13 10 to the power 13 right. I can write down 6.4 squared 6.4 squared right here. I can write down 4 into 3.14 squared right 10 to the power 13. Then here 360 0.1 into 3600 means 360 360 24. Forget about the 0. If I multiply 36 by 24, here it's 24, here 12, 14, 12, 7, 4, 6, 8. 8,640. 8,640 squared. 8,640 squared. 8,640 squared. 8,640 squared. This entire one, this much. 1 over 3 power. 1 over 3 power. Now I can divide this one by 4. If I divide this one by 4, here it's 1. Here I will obtain that 2. I will obtain 2 2160. 2160. Now we'll use our log. Okay, now we'll use our log. If you use our log, look at it. Now 64. Now I'll erase this section. I'll erase this one. If I erase this side, if I erase this side, now logbook. Now you also go through the logbook and support me, okay? Logbook. There is the logbook, okay, right? Now we have the logbook. Now, what is the log value of 6.4? 6.4 means 0.8062. 0.8062. 0.8062 squared into 2. Then we are getting here 2 into 2, 4. Here it's 12, 16, 1. Right. Then I can say 1.6124. What is the log value of 10 to the power 13? 13.0000. What is the log value of 2116? 3.216. 216. 216. 21 5 21 6 3345 3345 3345 3345 8,640. 8,640 means again 3.864. 864. 864. 864 means 9365. 9365. 864 means 9365. 9365. 9365. Then this section is covered. Everything is covered. Then 3.14. I want to add these 4. If I add these 4, I'm getting that. I'm getting here 10, here it's 14. 1. If I do any mistake, let me know, right? 10, 14, here it's 1. 10, 12, 1, 13. Then here again 1. 3, 6, 7, 8. Then here 9, 12, 12, 6, 18, 1. Then we are getting 3, 6, 9, 10, 11. Then 21.8834. Then 3.14. Log value of 3.14 means 0.314. 314. 31 4, 31 4, 31 4, 49 69, 49 69, 49 69 into 2 ni square ni. Then 18, here it's 13, 18, 19, 9, 18, then 12, 13, 18, 1, 19, 9. Then problem solved, 0.9938 subtract. And when you subtract it, you will get that. Here it's 6, here it's 6, here it's 9, here it's 8, here it's 8, it's 20. Then 14, 13, 18, 18, 21. Then whole power. Power is 103. Multiply by 103. Multiply by 103. Multiply by 103. That means divide by 3. Multiplying by 103 means dividing by 3. So then we are getting here. We are getting here 6, 18, 28, 9, 27, 6, 18, 3, 2. Now anti-log. Anti-log 9632. 9632 anti-log. 9632 anti-log. 9632 anti-log. 9632. 9632. 91, 91, 8. 91, 8, 8. 91, 8, 8. 91, 8, 8. 91, 8, 8 to the power 6. So therefore you are getting 6.4 into the power 6 plus simple h equals 9.188 9.188 into the power 6. So when you subject simple h, understand you are getting that 9.188 minus 6.4. 9.188 9.188 6.4. When you subtract 8, 8, 7, 2. 2.788. 2.788 10 to the power 6 meters. Did you understand? Raise your hands if you understood. If you understood, raise your hands. Two, yeah, I'm correct, right? Right? I think you guys understood. Okay. Right. Then say Roman number 1 is done. Roman number 2. So when you can see Roman number 2, they are asking calculate the total energy of the satellite. Calculate the total energy of the satellite in its orbit. Right. I erase this entire thing. I don't have a simple h value. If I erase this whole thing, I know simple h value. My simple h value is this height from the surface of the earth to satellite is simple h equals, now we know simple h value. Simple h is 2.788 10 to the power 6 meters. Okay, that was 6 meters. That is our simple h value. Now they are asking calculate the total energy of the satellite in its orbit. Now when the satellite is moving around this orbit, the total energy of satellite. Now the satellite is moving, therefore satellite is having kinetic energy. How do you find the kinetic energy? Half mv squared. If you want to find the kinetic energy, we can use half mv squared. And also, due to the location of satellite is having potential energy. So therefore, if you are finding total energy of the satellite, kinetic energy plus its potential energy, right? When satellite is orbiting around that particular orbit, satellite is having a kinetic energy as well as due to its location in the field, satellite is having a potential energy. So therefore, if you need to find total energy, you need to add kinetic energy plus potential energy, right? Then Roman number 2. Then Roman number 2, total energy. Total energy, we can say that kinetic energy plus potential energy. Kinetic energy plus potential energy. Kinetic energy plus potential energy. Now, can you remember what is the equation that we learned to find potential energy of simple M mass in the field? Minus G capital M simple M over R, right? Potential energy equation. Potential energy equation, potential energy W means that is minus G capital M simple M over R. So you must remember these equations, minus G capital M simple M over R. Kinetic energy equation, that is half mv squared. So I can write down half simple M, half simple M v squared minus G capital M simple M over R. R means this time capital R plus simple H. Okay, you want to understand here. R means capital R plus simple H. Capital R plus simple H. Capital R plus simple H squared. Am I correct? R plus H squared. Sorry, my bad. R capital R plus simple H. This is the potential energy equation, kinetic energy. Now the problem is, okay, now I don't know mass of the earth. Therefore, I can replace G capital M by simple G capital R squared. Gravitational acceleration capital R squared. But the problem is, I don't know velocity. That means tangential velocity of the satellite. I have no idea. I don't know. That is not given. Can you remember? I explained this one as well. Suppose if you don't know tangential velocity, what we do? We apply F equals ma. You consider circular motion of satellite, and for the satellite you apply F equals ma. Then you convert velocity in terms of G capital A. I don't know how many of you can remember. Suppose if they didn't give velocity, what you need to do is you consider circular motion of satellite. Circular motion of satellite. Satellite, again apply F equals ma. Satellite, apply F equals ma. So when you apply F equals ma, gravitational force G capital M simple M, G capital M simple M over R plus H ni, R plus H squared, R plus H squared equals simple M. Now this time centripetal acceleration. In Roman number 1, we wrote centripetal acceleration in terms of R omega squared. This time, as I want to obtain an expression for velocity, I write centripetal acceleration in terms of V squared over R. V squared over R plus simple H. Then simple M cancel out. Sorry, simple M ni, look at it. G capital M simple M, MV squared, R plus capital H. I can cut 1 R plus capital H to this R plus capital H. Then if I multiply both sides by half, I am getting that half mv squared. I am getting half mv squared as what? Half mv squared as G capital M simple M over 2R plus simple H. Did you understand? So take this as your equation 1. Substitute that equation 1 exactly here. I explained and we did some questions as well from equation 1. Now we can write down total energy. I gave separate note for total energy as well, if you can remember. Right? Half mv squared. That is G capital M simple M. G capital M simple M over 2 R plus simple H minus G capital M simple M over R plus simple H. Then what I do? I multiply this term by 2. If I multiply this term by 2 up and down, if I multiply the numerator and denominator by 2, then I can write down, very carefully listen, minus 2 G capital M simple M plus G capital M simple M. Then we can write down minus G capital M simple M over 2R plus H as your total energy. total energy. If you understood, raise your hands. Still we didn't finish yet. If you understood, raise your hands. If you understood, raise your hands. Right. Now G capital M. Now G capital M we can replace by simple G capital R squared. G capital M we can replace by simple G capital R squared, simple M 2R plus simple H minus. That is your total energy. Now substitute. If I bring here, if I bring this one here, now substitute. Then you are getting total energy minus G is 10, R squared 6.4 squared, 10 to the power 6 squared, 10 to the power 12. 10 to the power 12 into simple M is 1000 kilogram. Mass of the satellite is 1000 kilograms. 1000 over R plus simple H. 2 R plus simple H. R plus simple H. Capital R is 6.4. Simple H is 2.788. 6.4. 2.788. Then we are getting 8, 8, 11, 9.188. 9.188 10 to the power 10 to the power 6. Then when you simplify this, here 12, here 12, 3, 15. 10 to the power 6. 15 minus 6, 10 to the power 9. 10 to the power 9. 10 to the power 9, right? Then I can write down minus 5, 6.4 squared over, minus 5, 6.4 squared over 9.188, 10 to the power 9. Now when you simplify this, you will get the answer. If you simplify this, now how do you simplify this? If you simplify this, now again log me, again log, take your log now. Again I will use this one, I'll use this side. I'll write the log values in here. 5 means 0 point. What is the log value of 5? 5 means 0.50. Log value of 50. What is the log value of 50? Log value of 50, that is log value of 50. 6990. 6990. 6990. Then 6.4 squared. 6.4 squared, I think previously I took that. It's okay. 6.4. 6.4 means 0.64. How much? 64. Is it correct that 8062 is correct? Shall I put 8062? Is that correct? If not, okay, I'll do it. Okay. 6.4. How much? 6.4. 8062. 8062 squared. 8062 into 2. Then here it's 4, here it's 12, here it's 16. Therefore 1.6124. Then one can take, if you need, you can take this also 9.00 something if you want. If you want to take this one also in logs, you can write down 9.0000 if you need. Add them. When you add those three, we are getting here it's 4, here it's 11, here it's 11, 13, 11. Now here it's 4, 9, 11, 19, 11, 12, 1, 13, 19, 11. Then subtract that. That one 0 point, log value of 9188. Log value of 9188. Log value of 91. 9632. I take that. 9632, is that correct, right? 9188. I take that answer that you put in the chat box. I take it, right? 9632. Okay, 9632. I take that value. 9632. If I subtract it, I will obtain something. Here it's 2, 8, 4, 3, 10. Am I correct? 4, 11, 11, 13, 11. Anti-lock. 34, 82. What is the anti-log of 34, 82? 34, 82 anti-lock. 34, 82 anti-lock. 34, 82 anti-lock. 34, 82. 22. Roughly I take 22, 34, 84. 22, I take it as 22, 3. I take it as 22, 3. I take it as 22, 3. Okay, roughly. 22, 3, 10 to the power 10. Then your total energy is minus. Minus is must. If you forget to put minus, then the answer is wrong. In case if you don't include this minus value, your answer is wrong. The answer is 2.23, 10 to the power 10 joules. Simplification. Unless you don't practice this log simplification very well, it's very sorry for you. The next one. Then the next question. Roman number 3. Find the minimum energy required to take the satellite from the surface of the Earth to its orbit. I explained these things. I explained everything. Find the minimum energy required to take the satellite from the surface of the Earth to its orbit. Find the minimum energy required to take the satellite from the surface of the Earth to its orbit. Change in potential energy. That's the minimum energy, right? The Roman number 3, the answer is change in potential energy. Roman number 3, the answer is change in potential energy. Right. Right. Okay. Yes, in this case, if I erase this one, the Roman number 3. Now, Roman number 3, I erase this one. Roman number 3. Roman number 3. Minimum energy now. When you bring the satellite, very carefully understand, when you bring a satellite from surface of the Earth to the orbit, what is the energy, minimum energy that you need to provide? Minimum energy that you need to provide equals to change in potential energy. If you say potential energy at the orbit of the object, if you say potential energy at the orbit of the object as your W2, and if you say potential energy of the object on the surface of the Earth as W1, what is the minimum energy that you need to provide to move the satellite from the surface of the Earth to orbit? Change in potential energy, W2 minus W1. I think in one of the past episodes also I discussed the same thing. W2 minus W1. Minimum energy required. Roman number 3. Roman number 3. Minimum energy required. Minimum energy required. That is equal to change in potential energy. Change in potential energy. That means W2 minus W1. Now, what is W2? What is the gravitational potential energy of the object at the orbit? What is the gravitational potential energy at the orbit? Minus G capital M simple M over distance R plus simple H. R plus simple H. R plus simple H. R plus simple H minus W1 gravitational potential energy at the surface of the Earth minus G capital M simple M over distance to the object at the surface of the Earth from the center of the Earth, capital R, capital R, capital R. Then minus minus will become plus. Minus minus become plus. I bring this term front. G capital M simple M over capital R minus G capital M simple M over capital R plus simple H. Then here again you can take G capital M simple M as your common factor. You can take G capital M simple M as your common factor. If I take it as common factor, G capital M simple M as my common factor, 1 over r minus 1 over r plus simple h, right? Then if I bring to that side, I reach this one. I reach. Now next day onwards, I will do past papers from mechanics. Okay, again mechanics. I always say that recommend us. Study will. Now here G capital M means GR squared. G capital M means GR squared. GR squared. Simple M over simple M. Common denominator. R plus H. R plus simple H. Here. R plus simple H minus R. R plus simple H minus R. R cancel out. Then we get that something like this. We get one capital R cancel out. Then we are getting mg capital R simple H. Mg capital R simple H over R plus H. Now I say that when you do these questions, until your maximum possible step, continue the simplification only in terms of variables, right? If not, your simplification will become complex. So then now substitution. We want to substitute. Then we want to substitute. If you substitute, what will be the answer? If we substitute, the answer will be right. Simple M is 1000. Simple M is 1000. A simple M 1000. Gravitational acceleration, that's 10. It's 6.4. 6.4 10 to the power. Simple H value 2.788. Simple H value into 2.788 into, we don't have space. Okay, I will write this one here, 1000, 1010, 6.4 10 to the power 6. Simple H means 2.788. 2.7, 2.6 over 9.188, 9.188 10 to the power 6, 10 to the power 6, 10 to the power 6 cancel out. Then here 10 to the power 4, 10 to the power 4, 10 to the power 10, 10 to the power 10. Then we can write down here 6.4, 6.4 into 2.788, 2.788 over 6.4 into 2.788 over 9.188, 9.188, 6.4, 2.788 and the power 6, 9.188. So when you simplify this again using log, you will obtain approximately, okay, I will do the simplification. Okay, right. Now again take your logbook and find this. I don't like to do this log simplification, but most of you don't do. That's the problem. That's why I'm doing these things. And when you close to the exam, you don't know how to even look at the log. It's a problem. It's a very big problem. 64 means 0.8062. Yeah, thank you. 8062. 8062. What about this 2.788 0. I already found these log values, but I don't have the log values. I already found these log values. 0.2788. Anyone? 4453. I take your values, okay? Don't make it wrong. 4453. 4453. Adding these two. Here it's 5. Here it's 11. 5, 12, 1. 5, 11, 5, 12, 1. What about 9.88? 0. I got this log value as well. Anyone? 9.88. 9632. 9632. 9632 subtraction. H 3 8 ni. H 3 8 8 3 0. 5 11 15 5 11 15 yeah, there's a mistake. Now, it must be 2. Now 5 11 15 12 1, right? Anti-lock. 2883 anti-lock. 2883 anti-lock. 2883 anti-lock. 2883 anti-lock. 2883 2889 2883 2883 19 194 194 1942 1942 answer is 1942 1942 10 to the power 10 joules is the answer. If you understood, raise your hand that section also. If you understood, raise your hand that section also. If you understood, raise your hands that section as well. Then we discussed Roman number 1, Roman number 2, Roman number 3. Then Roman number 4 says that explain now. Someone tell me what is the value that we obtain in Roman number 2 total energy? What is the value that we obtain in total energy? Total energy equals how much? Someone put in the reply minus total energy equals. Now Roman number 2, I think we found total energy. What is the value that we obtain for total energy? Someone reply. What is the value that we obtain for total energy? Someone reply quickly. What is the value that we obtain for total energy? Someone reply quickly. Someone reply minus 2.23 10 to the power 10. Minus 2.23 10 to the power 10. Minus 2.23 10 to the power 10 joules. Right now, what is this energy? This is the minimum energy that we want to provide for the satellite to move from the surface of the Earth to the orbit. Then Roman number 4 they ask. Roman number 4 they ask. Explain why the values obtained for Roman number 3 and Roman number 2 are different. Because Roman number 2, this value is about total energy when satellite is moving in that orbit. Roman number 3, that is the amount of energy that we want to provide, a small part of the energy that we want to provide for the satellite to move from the surface of the Earth to the orbit. So therefore, that's the difference. Okay, if you write that, you will get the answer. You will get the marks. Roman number 5. At what height above the Earth's surface the satellite must orbit to be a geostationary satellite? That's very good thing. That's very good question. It's a good question. Question says that at what height above the Earth's surface? At what height above the Earth's surface the satellite must orbit to be a geostationary satellite? Then we learned that what is the requirement to have a geostationary satellite? If a satellite is geostationary, what can we say about the time period? Reply. If a satellite is a geostationary satellite, what can we say about the time period? Reply the chat box. If a satellite is a geostationary satellite, what can we say about the time period? Reply in the chat box. What can we say about the time period of satellite? Quickly, reply in the chat box quickly. 24 hours, ni? 24 hours. If a satellite is geostationary satellite, time period is 24 hours. Then they ask that in order to convert the satellite to a geostationary satellite. Now you understand what is the time period of current satellite? Time period of current satellite is 1 over 10. When you consider day, 1 over 10 day. How do we say in English now? How do we say in English? Now time current, when you consider current satellite, its time period is 1 over 10 days. 1 over 10 days. But if we want to make the satellite as a geostationary satellite, we know that its time period must be 24 hours. If we want to make the satellite to a geostationary satellite, we know that its time period must be 24 hours. Now, how do we increase the time period? We want to convert 1/10 days time period into 1 day time period. So in order to do that, how can we do this one? So we can do by changing the radius. That means change the distance. So when you change the height, automatically you can change the capital T time period. Then look at it. Then they are asking, explain at what height above the Earth's surface satellite must orbit to be a geostationary satellite. Right. In that case, okay, the last one. Then we can take a break. Then we'll do 2011 essay question as well. Then entirely one section is fully completed. Right. It's not easy as you think covering everything, but I thought of give a small effort and check. Based on your results, I will decide what will you do in coming batches. Because as a batch, 23 batch is very unsuccessful. But I think that I know that the count does not matter. So no matter I have 50, 100,000, that does not matter. That whatever the count that I have currently, I want to make them to a maximum result. So I put my maximum effort, and we'll see that now we have 10 more months, right? 10 more months we have available. Then we'll see. We'll see. Right now, time period. Now, just think about this satellite is geostationary. If you think this satellite is geostationary, time period must be 24 hours. Time period must be 24 hours. Now, when you apply F equals ME, so same scenario. If you apply, because now current now you need to obtain an expression for time period. When you apply F equals ME, when you apply F equals ME, F equals ME, gravitational force G, capital M, simple M. Now think the total distance. Just think the total distance. Now your satellite is geostationary. They think that distance to the satellite from the center of the Earth is, let's say, simple b squared. Just think it has simple b squared, simple m. Centripetal acceleration I consider r omega squared. That means b omega squared. Omega squared means what? 2 5. What is omega squared? Omega squared means t equals 2 5 over omega. Omega squared means 2 5 over capital T. 2 5 over capital T whole squared. 2 5 over capital T whole squared means 4 5 squared over capital T squared. I hope you understand these things. 4 5 squared over capital T squared. Simple M cancel out. Again, G capital M means G R squared. If I bring B squared that side, B cube. Here it's capital T squared. Now, previously we derived this equation. Now, you don't need to derive this equation again. I think in Roman number 1, we derived very similar equation. Then you don't need to derive again. Then you can see the time. But currently, I can't because I erased everything that I wrote under Roman number 1, 2. Therefore, I need to derive it again for your understanding. So I do this much of steps and I take this much of time to explain you every single step without missing every single step I explain. B cube, T squared, 4 5 squared. Now again substitute and you will get the answer. Right, substitute then you will get the answer. Then we can write down now. Now time period. Geostationary satellite. If the satellite is geostationary satellite, we know time period is 24 hours. I know G is 10. Radius of the Earth is 6.4 in the power 6 meters. 5 means 3.14. Then find B value. Then that's the answer. They are asking at what height above the Earth's surface. After you found simple B, subtract the radius of the Earth. Then you will get the answer. Right now, if I subject simple B equals G R squared capital T squared over 4 5 squared 1 over 3. Now substitute these values. When you substitute these values, you will get a value for simple B. Okay, I'm not going to do this one because we took so much time. We will get a value for this one. Okay, substitute because capital time period is 24 hours. Convert to seconds. Capital R means 6.4 to the power 6 meters. G means 10. substitute those values, then you will get the value for simple b. If you want to find the height, simple h, subtract ni. If you need to find the new height, h dash, new height h dash means simple b. Now total distance to the satellite from the center of the earth is simple b, subtract the radius of the earth, then you will obtain the height to the geostationary satellite from the surface of the earth, right? Then you will get the answer. Raise your hands, how many of you understood this one? Understood. Raise your hands if you understood. Raise your hands if you understood. Raise your hands if you understood. Then if a satellite in orbit loses energy due to friction, what happened to the speed of the satellite and the radius of the orbit? If a satellite in orbit loses energy due to friction, what happens to the speed of the satellite and the radius of the orbit? Radius of the orbit will be uh, decreased, velocity increase. Now, that's small thing. Now we know what is the equation for velocity. We know that velocity equals g capital M over r square. Now when a satellite loses the energy, it's getting closer to Earth. Therefore, radius is decreased. When radius decreased, velocity has increased. Therefore, when a satellite is losing its energy due to friction, understand that radius decreases, right? Velocity of the satellite increases, right? Okay. Did you understand? Did you understand? Did you understand? Raise your hands if you understood these things. Okay, yeah. If not, I will do this one. I will do this one. Okay. I will do this one again. If I substitute g value, simple b equals now g means 10, radius again 6.4 squared. Radius 6. Now, but we can do something like this as well. Now look at it. Now we can do something like this also now. This is one way. Okay, I will do in this way also now. We can take that now. T squared equals T squared is proportional to distance squared, distance cube. T squared proportional to distance cube. I will explain these methods later, right? Now, as we substituted until here, we'll find the answer by doing the substitution. 6.4 10 to the power 6 squared. 6.4 squared. 10 to the power 6 squared means 10 to the power 12 into now time period. Now time period is 24 hours. Now 24 into 3600 whole squared. Now time period is 24 hours into 3600 whole squared. Am I correct? Then divide by 4 into 3.14 whole squared. 1 over 3. Okay, you find the answer. Then you find simple b and subtract the radius capital R. Then you will obtain the answer. Now I think you can do it. Now there is another way as well. Can you remember in the very beginning of the question they mentioned that? In the very beginning of the question they mentioned the time period. Now you can understand that from this equation you know that g radius phi, this entire thing is a constant. Am I correct? This equation you will understand that g r squared 4 phi squared is a constant. Time period squared, understand time period squared directly proportional to distance to the satellite from the center of the earth. Time period squared is directly proportional to distance to the satellite from the center of the earth. I say simple bq. Now previously you found that means r plus h. Previously the time period of satellite is 1 over 10. Previously time period of satellite is 1 over 10. That means 0.1 day squared directly proportional to, you know, previous case. Previously, what is the distance to the satellite from the center of the earth? 9.18. I can't remember. I think 9.188 10 to the power 6 cube, right? This is proportional to 1. Now when the time period is 24 hours, that means 1 day, you need to find that new simple b cube is your proportional to 2. If you divide proportional to 2 by proportional to 1, then also you can get the answer. We can write down b cube over 9.188 10 to the power 6 cube equals 1 over 0.1 squared, right? Then I can say that b equals 9.188 10 to the power 6 into 1 over 0.1 squared 1 over 3. Then you can easily get the answer. No matter you found the answer in this way or in this way, you will get the same answer. Then here 0.1 squared means you can do it. You can do it. Okay. Raise your hands. Everything is very clear. This question. Raise your hands if you understood everything. Now, for the students who revised everything and who read all the questions, who follow what I say, obviously I know that they can understand. If a student who could not understand, that's because of they didn't cover the theory, they missed one of the classes. If not, they didn't do the homework, they didn't read the questions, they didn't join for last previous past sessions. Then I can't take the responsibility of them, right? Every day we can't say they do this, do that. I'm also very tired of doing that. Okay, now time is 8:30. We'll take a break of 10 minutes. Now come at 8:40. Come at 8:40. Now time is 8:30. Come at 8:40. HSA question 30 minutes. If you practice well, you can do this question within 30 minutes. If you practice well, you can do this essay question within 30 minutes. If you practice well. Now someone reply if you can hear me speaking. Someone reply if you can hear me speaking. Right, okay. I will discuss now 2011 A level. 2011 A level question. 2011 A level question. Right. Now just read the question very carefully. Use the satellite is use of satellite is expanding due to many application in areas such as communication, meteorology, defense, and science exploration about the Earth as well as outer space. Satellites are placed on certain orbits depending on the applications. Satellites are placed on certain orbits depending on their application. The gravitational force provides the required centripetal force. The gravitational force provides the required centripetal force to maintain a satellite in orbit. Right? We know those things. We know those stories because we learn because of the gravitational force only. We know that those satellites are orbiting around different orbits. We know these ideas. We know this story. Then they say that the gravitational force provides the required centripetal force. Okay, to maintain a satellite in an orbit. Okay, we know that geosynchronous satellites. Why? What is this geosynchronous satellites orbit the Earth with a period of 24 hours. That means geostationary satellites. Another word for geostationary satellite is geosynchronous satellite. You understand? Then geostationary satellite means we know we know what is the meaning, what is the idea of geostationary satellite. Then geosynchronous satellite means another word to say geostationary satellite. All right. Geosynchronous satellites orbit the Earth with a period of 24 hours, thus matching the period of the Earth's rotational motion. Thus matching the period of the Earth's rotational motion. Because we know that when we consider our Earth, the rotational time period of the Earth is 24 hours. If a satellite having 24-hour time period means we call that satellite as geostationary satellite. If not, we say that now, as that paragraph says, geosynchronous satellite. Right. A geostationary satellite is a geosynchronous satellite. A geostationary satellite is a geosynchronous satellite in an approximately circular orbit on the plane passing through the Earth's equator. Geostationary satellite is a geosynchronous satellite in an approximately circular orbit on the plane passing through the Earth's equator. Now, when I explain theory, I detailly explain that what is geostationary satellite. I explain very detailed. Explain that, right? Okay, we learned that thing also because geostationary satellites are placed exactly in the plane passing through the equator. Can remember I told that geostationary satellite they are placed in a plane passing through the equator. We know those things as well. Okay, right? We know that idea. අපි ඒක කාරණාව දන්නවා. That appears motionless in the sky because geostationary satellites, relative to a fixed point on the ground, satellite is fixed. Relative to a point on the ground, your satellite is fixed. That's what we call as geostationary. Mm, Motionless in the sky to a ground observer. The idea of a geostationary satellite was first proposed by the science fiction writer Arthur C. Clarke. The idea of a geostationary satellite was first proposed by the science fiction writer Arthur C. Clarke. Communication satellites and weather satellites are often given geostationary orbits as they can continuously observe the same areas on the Earth. Communication satellites and weather satellites are often given geostationary orbits as they can continuously observe the same areas of the Earth. Geostationary satellite used Directional antennas for communication with communication with communication with uh, communication with ground stations. There are also several disadvantages of a satellite being operated as a geostationary satellite. The number of satellites that can be maintained in geostationary orbits without interfering with one another is limited. The there are also several disadvantages of satellite being operated as a geostationary satellite. The number of satellites that can be maintained in geostationary orbits without interfering with one another is limited. An electromagnetic signal emitted from a ground station travels at a speed of 3 into 10 to the power 8 ms minus 1. Due to the great distance in the satellite, a significant time delay is introduced between the original signal emitted from the Earth station and the signal received by another station after traveling via a satellite. Now, this is something like this. Now, you need to understand now. Just think that now. Now, let's say now you take a call. Let's say that now you take a call. Now, one of your family member is in US, but currently you are in Sri Lanka. Now you are taking a call, right? This is our Earth. Now here, this is Uni. Here is Sri Lanka. Now exactly here is US. Then when you take a call, that signal, electromagnetic signal, ne, that electromagnetic signal first transferred to the satellite. Then satellite transfers that signal to the person in the US country. Then you need to understand. So there's a delay, right? Because satellite is very far from the Earth, right? So therefore, when traveling the signal from Sri Lanka to the US, from Sri Lanka to US, there might be some sort of time delay because it takes some sort of small time. It's not a big delay, but some sort of time delay, right? Okay. Due to the great distance in the satellite, a significant time delay is introduced between the original signal emitted from the Earth station and the signal received by another station after traveling via a satellite. Okay. Furthermore, due to the greater height, the clarity of pictures of Earth taken by geostationary satellite are poor, especially at locations away from the equator. Now you can understand these stories. Another problem would be the damage caused by the EM radiation, electromagnetic radiation from the sun when a geostationary satellite comes lower to the sun, especially when the sun passes through the equatorial plane at the late March and late September. Now the last paragraph, low Earth orbit satellites. Now there are another type of satellite. Now like geostationary satellite, now there are another type of satellite, low Earth orbit satellite, LEOs. Low Earth orbit satellites, typically operating at the height of 162,000 kilometers from the surface of the Earth with shorter periods, have become popular in recent days, right? Their orbits could be on any plane passing through the center of the Earth. Their orbits could be any planes passing through the center of the Earth. However, for continuous data acquisition pertaining to a specific location, observation of weather over a given country, a system of group of LEOs is needed. Some advantages of a LEOs are the use of simple non-directional antenna, reduced time delay for electromagnetic signals, higher clarity pictures of the Earth, and less electromagnetic radiation from the sun. Also, it needs less energy and resources to place a satellite into a low Earth orbit and need less powerful amplifiers for successful communication for a satellite which passes over the poles of the Earth is special case polar satellites of LEOs. Hubble telescope is another example for LEOs. For scientific exploration of our space, oh, how long this paragraph? For scientific exploration of outer space, experiments are conducted in observatories placed on the orbits which are far away from the Earth. There are four specific locations called Lagrange. It's not Langevin, it's Lagrange points. Okay, I will explain separately in paper class. I will explain what are these Lagrange points. Not right now. I will explain the paper class. Okay, there are four specific locations called Lagrange points on or capital L points when satellite could be placed to perform such experiments. Satellites placed at capital L Lagrange points appear stationary relative to the Sun-Earth system. The following figure shows two of Lagrange points called L1 and L2 when the Earth orbits the Sun with a period of 1 year. When the Earth orbits the Sun with a period of 1 year, satellite placed at L1, L2 also move with the Sun Earth system, but the relative location of them remain the same. There are four satellites at the vicinity of L1 and three satellites, including the latest Planck Space Observatory, have been placed at the vicinity of L2. L2 is especially useful for observation of outer space because the Earth partially blocks solar radiation falling to the satellite at L2 through the motion. What is the value? What is the value of period of geostationary satellite? Here G capital is S. Now look at the question. Right. Whew. Now very carefully listen. The last question. The last question. The last question. Right. It's a very huge paragraph that I read. The last question. 2011 A level. 2011 A level. 2011 A level gravitational field. Now Roman number 1. Simple A. Sorry. Simple A. Simple A. I think I missed a diagram. I think in that tute, that 2011 A level essay question, I could not include a diagram. There must be a diagram, right? Okay, I will send the diagram after I explain certain amount of questions in 2011 A level. Simply, now simply, what is the value of the period of a geostationary satellite? Geostationary satellite, what is the time period? Time period of a geostationary satellite is 24 hours. 24 hours. 24 hours. If not, we can say 1 day. 24 hours. If not, we can say one day. Now simple B. Simple B. Draw a three-dimensional diagram of the orbit. Draw a three-dimensional diagram of the orbit of a geostationary satellite around the Earth. Draw a three-dimensional diagram of the orbit of a geostationary satellite around the Earth. Clearly indicate the geometrical north, south, equatorial plane of the Earth. Right. Now let's say now this is our Earth. Right. If we see this as our Earth. Right. So now our north and south. Now here is our north. Now here is our north. Here is our south. Now just say that this red color line represents the equator. Red color line represents the equator. Right. This is the equator. The equator. Then our Geostationary satellite. We know that now. Always we place the geostationary satellite in the plane passing through the equator. I explained. Geostationary satellite is placed exactly on the surface passing through the equator. So therefore, this is your geostationary satellite, the plane, right? It's your geostationary satellite. It's your satellite. Now your plane would be. This is how your plane would appear. This plane must be passing through the equator. Did you understand? Right? I think you guys understood that idea. Next question. Next, give an example for a Leo. Now, give me some examples for Leos. If you read that one carefully, now you can read and you can get the answer. Example for Leos. Polar satellite, Hubble Space Telescope, International Space Station. Ola, Leos. Simple C. Simple C. Polar satellite. When you read the entire paragraph, you can get this answer. Very easy answer. Polar satellite, Hubble, Hubble telescope, Hubble telescope, Hubble Space Telescope, International Space Station, Hubble Space Telescope. Likewise, you can write down something else. Now simple D. Now simple D. Obtain an expression for the radius of a geostationary satellite. Obtain an expression for the radius simple R. Obtain an expression for the radius simple r of a geostationary satellite in terms of universal gravitational constant capital G, mass of the Earth m capital E, and the period capital T of geostationary satellite. Substitute the correct numerical values in the expression. Uh, yeah, right. Okay. No need to simplify the answer. Now look at here. Now if I say this as my Earth, now here is my Earth. Here is my Earth. Okay. Now, geostationary satellite. Now, there's a geostationary satellite in an orbit. This is the orbit. Geostationary satellite is orbiting around an orbit. Orbiting around an orbit. Right? Then they mentioned. They mentioned. We need to find an expression for the radius of the geostationary satellite. Obtain an expression for the radius simple r of a geostationary satellite in terms of. Now, if I say that the distance from the geostationary satellite to the center of the Earth, the radius of the orbit. If I consider radius of the orbit as simple r, if I say radius of the orbit as simple r, we need to find simple r in terms of. We need to find simple r in terms of capital G, simple r in terms of capital G, mass of the Earth m capital E, time period of the satellite, geostationary satellite capital T. This is my geostationary satellite. This is my Earth. This is my Earth M capital E. Do you understand? Right? Okay. Then in that case, now what we do? We consider circular motion of geostationary satellite. Right now, this satellite is moving in a circular motion. We consider circular motion of this geostationary satellite, and we apply F equals ma equation. Right? We apply F equals ma equation. Right? We apply F equals ma equation. Right? Satellite, geostationary satellite. When you apply F equals ma, when you apply F equals ma equation, F equals ma equation. Now, capital F means gravitational force acting on the geostationary satellite. Capital F is gravitational force acting on the geostationary satellite. We can write down that gravitational force as G capital M E. I say mass of the satellite. Let's say mass of the geostationary satellite is simple limb. If I say mass of the geostationary satellite is simple limb, we can write down capital F as G mass of the Earth me, mass of the satellite simple limb over simple r squared, simple r squared, simple m centripetal acceleration. Now I need to find simple r, centripetal acceleration. They have given time period capital T. Now we want to find simple r. We want to find simple r in terms of time period. Then the best option is going with r omega squared. R omega squared. Now we know omega. T equals 2 5 omega. Omega means 2 5 capital T. Here simple m cancel out. G capital M E. I can bring this r square this side. R cube. R cube. R cube. Omega squared. Omega squared I can write down it as 2 5 over capital T whole square. Then I will obtain that r cube by subject r cube. R cube equals G capital M capital T squared over G capital M E, my bad, G capital M E capital T squared, G capital M E capital T squared over 4 5 squared, 4 5 squared. This is your r cube, but you need to find simple r. When you subject simple r will be G capital M E capital T squared 4 5 squared. Then I can obtain simple r only in terms of me G capital T. 1 over power is 1 over 3. Right now we obtain an expression for simple r in terms of G capital M E and T. Question further says that substitute the numerical values in the expression. No need to simplify the answer. Now they given G capital M E equals 40 into 10 to the power 13. G capital M E they mention G capital M E means 40 into 10 to the power 30. 40 into 10 to the power 30 time period it's a geostationary satellite. So time period of geostationary satellite is 24 hours. 24 hours, 3600 seconds whole squared over 4 into 3.14 whole square. We don't need to substitute. Sorry, we don't need to simplify. It is mentioned in the question. Now, this is your final answer, simple R. This is your final answer, simple R. Then I found simple D as well. I found simple D. Simply calculate the time delay in receiving an electromagnetic test signal. Calculate the time delay in receiving an electromagnetic signal emitted from a ground station to a geostationary satellite located 36,000 kilometers vertically above it. If the signal is received again, it's very, you need a S equals ut equation. The time taken for a signal emitted from the Earth to receive back to the Earth. The time taken by the signal emitted from the Earth to be received back to the Earth, the time delay, the time taken. Now we need to find that simply. How do we find simply? Now simply, if I find simply, we can apply is equals to. Now look at it. Now simply, I will erase here simply. A, B, C, D done simply. The last question is simply. Now simply, now let's say now this is our Earth. This is our Earth. Now here is our satellite. This is our satellite. This is Earth satellite. This is our satellite, our Earth. Then they ask time delay. Now, initially signal is transmitted from the Earth. Initially signal is transmitted from the Earth. That signal is received to the. That signal is transmitted from the Earth to the satellite. Again, that signal is received to the Earth. Right now, they mentioned distance between the Earth and the satellite is distance between the Earth and satellite. Ground station to a geostationary satellite located 36,000 kilometers vertical above it. Now this gap distance from the surface of the Earth to the satellite, this gap is 36,000 kilometers above it. Then they ask time delay. But as these waves are electromagnetic waves, what is the speed of electromagnetic waves? When you consider any electromagnetic wave, their speed in a vacuum is 3 into 10 to the power 8 ms minus 1. Their speed is 3 into 10 to the power 8 ms minus 1. Then what is the total distance traveled by the signal? Now just think about the motion of these electromagnetic waves. When t equals 0, just think that this electromagnetic signal is emitted from the ground. When t equals 0, this signal is emitted from the ground. Now, after simple t time later, the signal is received back to the ground. Then what is the total distance traveled by the signal? 36,000. This direction, again come back to the ground. Again another 36,000. Altogether, the total distance is 36,000 kilometers into 2. If I apply S equals ut equation, total distance traveled by the signal 36,000 kilometers. If I want to convert meters into the power 3 into 2, you know why? It's why I multiply by 2, because signal is traveled 36,000 kilometers upwards, again came back to the ground, another 36,000 kilometers down, equals. Now you find the time. Velocity is how much? If I subject simple t, what is the velocity of the signal? Velocity of the signal is velocity of the light 3 into the power 8 ms minus 1. Then when you subject the time simple t, you will obtain that. Here it's 12 into 24, 10 to the power 3, 10 to the power 6, 10 to the power 3, 10 to the power 6, 10 to the power 8, 10 to the power minus 2. That means 10 to the power minus 2, 0.24 second delay. See, it travels this much of larger distance, but it takes the time taken to reach back to the Earth is about 0.24 seconds. Very small time. Very small time. Very small time. Raise your hands if you understood up to here. If you understood up to here, raise your hands. Raise your hands if you have understood up to here. All right. Now next, simple. Then simple A, B, C, D, simple E. Simple E. That is done. Simple F. The International Space Station orbiting around the Earth is in an orbit. International Space Station orbiting around the Earth is in an orbit with a radius of 6,700 kilometers inclined to the equatorial plane. International Space Station orbiting around the Earth is in an orbit with a radius of 6,700 kilometers inclined to the equatorial plane. Calculate its period. Calculate its period. Is this a geostationary satellite or LEOs? Now, now, time period. You need to find the calculate the time period, right? Now, if I erase again this diagram, simple if that's easy, it's not difficult. Now, this time, now if I erase this one, now I need to find the time period, right? Now, I'm not going to derive the now in that simple F also in question simple F also they say about some sort of satellite. So when you apply F equals MA, G capital M simple M cancel out. Somehow, even you derive it, it would end up with this equation. So I take this equation as equation number one. If I take this equation as equation, because we don't need to derive it again, because even you derive it again for simple F also, you will end up with same result here. So then I write on this equation. In this from equation one. From equation one, we can say that R cube equals G capital ME. R cube equals G capital ME T squared over 4 5 squared. 4 5 squared. G capital ME T squared over 4 5 squared. Now they ask that time period. Now we need to find the time period. We need to find the time period. If I subject T squared, I am getting I am getting T squared equals 4 5 squared. T squared equals 4 5 squared R cube. 4 5 squared R cube G capital ME. G capital ME. Right? Now, when I substitute, if I substitute 4, 3.14 squared, what is my simple R? Now they have given simple R. They have given simple R value. They have given simple R value as 6,700 kilometers. The International Space Station orbiting around the Earth in an orbit with a radius of 6,700 kilometers. Now R is 6,700 kilometers. R is 6,700 kilometers. 6,700 kilometers. If I convert to meters to the power 3 whole cube over G capital ME value they have given 14. Previously they gave previous question they gave 40 10 to the power 13. 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 Yeah, simplify this. Now when you subject time period T equals power is half. Total power is half. Then when you simplify this right now, you need to simplify this properly. Okay, we'll use the logger. We'll simplify this now 9:15. Now we started that roughly 7:15, 8:59. It's been 2 hours. We'll simplify this one. Okay, when we simplify this, we can simplify, but it takes time. That's the problem because so much time we take because of now I am doing the simplification as well. That's the problem. A simple if now to complete that question, I need to do simple G and simple H, right? Okay, now they have given 67. Now they gave a hint. Root 67 cube. Root 67 cube. Take it as 548. Now, okay, they asked us to consider 5 squared as 10. They asked us to consider 5 squared as 10. and G capital M mean this value in 4 in the about 13 R cube and R cube. Okay, now I will simplify further. But they have given some sort of hint. 67 cube whole root. They asked us to consider 548.4. For the easiness of the simplification. For the easiness of the simplification. If I further simplify this here, 40 cancel out. Then if I take 67, I can write down 67 into 100, 6,700 means I can write down 67 into 100, right? 67 into 100, 67 cube, 67 cube, 100 cube, 100 cube, 67 cube, 100 cube into 10 to the power 9, 10 to the power 9. Am I correct? Right? 67 cube, 100 cube, 10 to the power 9, 10 to the power 30. Entire power is half. Right? Then I can write down now power 10 to the power 9, 100 cube. 100 means 10 to the power 2, 100 means 10 to the power 2, 100 means 10 to the power 2, 10 to the power 2 whole cube. That means 10 to the power 6. You understand? 100 means 10 to the power 2 whole cube is 10 to the power 6. 10 to the power 6, 10 to the power 9, 10 to the power 15, 10 to the power 13. That means 10 to the power 2. 10 to the power 15, 10 to the power 13 means 10 to the power 2. That means 100. That means 100. Then we are getting equals 67 cube, 67 cube, 100. 67 cube, 100. If I separately get the root, we are getting something like this. Then they mentioned that 67 cube root, they asked us to take it as 548.4. 5 for the easiness. See, if not, we have to take the log and we're going to do the simplification. 548.4 root 100 means 10. So therefore, we get the time period capital T equals 5,484 seconds. 84 seconds. Right, give 3 advantages of LEOs. Now you can read the paragraph and you can write down the advantages. Now one advantage is reduced time delay of electromagnetic signals. Other one is possibility of using of simple non-directional antennas, high clearly phone calls or whatever. That is also easy. The simple F part is the very important part. Simple F1. Simple F is the important part. Simple is F. Why is the location L2 better for placing an outer space observatory? Not simple F part, simple H part. That is the very important section that I want to teach you. But I don't explain simple H. The last sub question I won't explain right now. But obviously I will teach you separately this Lagrange points. I want to tell you what is Lagrange points. On that day I will tell you simple H part. Then forget about the simple H part. But you try if you have resource books and if you have if you have that review books, go through the review books and refer them. I think I discussed other than simple H, I think I discussed everything. Now my job for Unit 5 is completely done. Yes, I discussed everything. No, hereafter I won't know any essay question other than these questions. Right? Then we discussed MCQs, essays, completely done. My advice is at least for one time, take this entire week. At least for one time, read all the MCQs and essay questions in these past papers. At least for one time. You will get a solid knowledge. Right? You will get a solid knowledge. The today's session is completed. Study well. Now hereafter we are doing again we are going back to mechanics MCQs because we have to discuss plenty of past paper MCQs from mechanics. Hereafter we are doing mechanics MCQs. Yeah, that's the idea. Right. We'll meet on next day. Have fun.